Hello friends, we are going to discuss about the porous plug experiment. This is the arrangement of this porous plug experiment. In this diagram, this is the porous plug which is connected to this spiral tube. The tube is immersed in the water. This is the piston. This is the experimental gas. And to measure the pressure, there is a pressure cross. This is a Porous tube. These T1 and T2, these are the two porous plugs. T1 and T2, these are the two sensitive platinum resistant thermometers. These are DD, are the perforated brass disc. This is jar J. This is the cotton wool or silk fibers. This is the wooden box. This porous plug is kept in this wooden box, which is surrounded by these cotton wool or silk fibers. Uh, so in this experiment, this gas is compressed by using this piston. So the pressure is created and the gas is compressed in. And for the cooling system, this spiral tube is kept in this water. This so the to measure the pressure, there is a pressure gauge which is connected to this porous plug. So in this, the experiment setup for the porous plug experiment to study the Joule-Thomson effect, which is shown in this figure. It consists of the porous plug having two perforated brass discs D and D. The space between DD is packed with cotton wool or silk fibers. The porous plug is fitted in cylindrical box wood W, which is surrounded by a jar J containing the cotton wool. This is done to avoid the loss or gain of heat from the surrounding, and the T1 and T2, these are the T1 and T2, these are the two sensitive platinum resistance thermometers, and they measure the temperatures of the incoming and outgoing gas. The gas is compressed to high pressure with the help of this piston P and is placed, and it is passed through a spiral tube which is immersed in water bath maintained at constant temperature. If there is any heating of the gas due to compression, this heat is absorbed by the circulating water in the water bath. The experimental procedure is by compressing this compression pump, the experimental gas is passed slowly and uniformly through this porous plug, keeping in keeping the high pressure constant, which is read by this pressure gauge G. During the during its passage through this porous plug, the gas is throttled, that is, separation between the molecules increases. On passing through the porous plug, the volume of the gas increases against the atmospheric pressure. As there is no loss or gain of heat during the whole process, the expansion of the gas takes place adiabatically. The initial and final temperatures are noted by the means of the platinum thermometers T1 and T2. The behavior of the large number of gas was studied. Various inlet temperatures of the gas, and the results obtained that is at sufficiently low temperatures all gases show a cooling effect. At ordinary temperatures, all gases except hydrogen and helium show cooling effect. Hydrogen and helium show heating instead of cooling at room temperature. The fall in temperature is directly proportional to the difference in pressures on two sides of the porous plug. The fall in temperature for a given difference of pressure decreases with rise in initial temperature of the gas. It was found that the cooling effect decreased with the increase of initial temperature and become zero at a certain temperature, and at a temperature higher than its temperature instead of cooling, heating was observed. This particular temperature at which Joule-Thomson effect changes, it's a sign called temperature of inversion. So temperature of inversion uh, means the temperature at which Joule-Thomson effect is zero and changes its sign is called as a temperature of inversion. It is denoted by Ti, means formula is 2A upon RB. Here A and B are the van der Waals constants and R is the universal gas constant. For the helium, inversion temperature is about 35 K, and for hydrogen, inversion temperature is 193 K. When if the gas is at temperature T equal to Ti, there is no heating or no cooling which is observed. When initial temperature is greater than the temperature T, the cooling takes place, and when T is greater than inversion temperature, there is heating takes place. So this porous plug experiment consists of this porous plug which is fitted in this jar which is surrounded by the wooden box W to avoid the surrounding temperature, and this there are the two perforated brass discs D and D. The two sensitive platinum resistance thermometers T1 and T2. This is for the incoming gas and this is for the outgoing gas. Measurement of the temperature of this incoming and outgoing gas. This porous plug is connected to this spiral tube which is immersed in the water. Here is the compressor, consists of piston, is this experimental gas. When this piston is moved, the gas is compressed and passes through the spiral tube, means it creates some temperature. To maintain the temperature, the cooling system is required. So this is the water vessel for the cooling system, and this spiral tube is connected to this pressure gauge to record this pressure here, and this is the arrangement of this porous plug experiment. And inversion temperature means the temperature at which Joule-Thomson effect is zero and changes sign is called as a temperature of inversion Ti. When if the gas is at temperature T equal to Ti, no cooling or heating effect is observed, and when the temperature is less than inversion temperature, the cooling takes place, and when temperature is greater than inversion temperature, the heating takes place. For the helium, the inversion temperature is about 35 K, and for hydrogen, the inversion temperature is 193 K. For the formula for the inversion temperature is Ti equal to 2A upon R into the B. Here A and B are the van der Waals constants, and capital R is the universal gas constant. So this is all about the inversion temperature. denoted by Ti, and this is the construction for the porous plug experiment. Thank you.